Hello, welcome to the practice midterm for college algebra. You'll have to forgive me, I don't have access to my fancy Wacom tablet at work. I'm having to work from home. So we're going to be doing the practice midterm on my Galaxy Note 10 Plus here. So let's get started. We've got problem number 1, solve the absolute value equation. Here we're going to try to get the x by itself. And the first step is we're going to have to get rid of the plus 10. So we're going to minus 10 from both sides. Plus 10 minus 10 cancel. So that's going to leave 5 absolute value of 2x minus 7. 18 minus 10 is 8. Okay, next step is to get rid of this 5. It's multiplied by the absolute value, so we're going to have to divide both sides to get rid of it. 5's cancel, leaves me the absolute value of 2x minus 7 equals 8/5. So at this point, we have the absolute value isolated, and since this number over here is a positive number, that means that this is going to split into 2 separate equations, okay? So let's see here. So that means we're going to have 2x minus 7 equals to positive 8/5, and we're going to have 2x minus 7 equal to negative 8/5. And then we'll have to solve each one of these for x. All right, so for the first equation, we're going to add 7 to both sides. Negative 7 plus 7 cancels, gives me 2x equal to, all right, so here we have 8/5 plus 7. And if you're like me, you're going to have to use your fancy calculator. 8/5 plus 7. That's going to give me 43/5. And then I'm going to have to divide both sides by 2. And so 43/5 divided by 2, that's the same as 43/5 multiplied by 1 over 2. And so that's going to be 43/10. And that's one of the answers. For the other equation, again, we're going to add 7 to both sides. 7 minus 7 cancels, leaves me 2x equal to, okay, here we have negative 8/5. With the calculator, that's going to be 27/5. Again, divide both sides by 2. And so that's going to give me 27/10. And so there's the first problem done. Solve the absolute value equation. We got our 2 answers. All right, moving on to the next problem. Find the function value. We want to find f of a minus 3 for this function. Now what that means, it means to plug a minus 3 in for each x. So that's going to give me f of a minus 3. That's going to be a minus 3 squared, because the a minus 3 took the place of the x, and so now that's all squared, minus 4 times a minus 3. Again, the a minus 3 took the place of the x, plus 7. Okay, and then we're going to need to evaluate this. So a minus 3 squared, that means a minus 3 multiplied by itself. That's a binomial times a binomial. That's going to indicate the FOIL method. The negative 4 can go ahead and distribute, giving me negative 4a plus 12. And the plus 7 comes down. All right, doing the FOIL method, a times a gives me a squared. On the outside, negative 3a. On the inside, negative 3a. And last but not least, negative 3 times negative 3 makes plus 9. Minus 4a. And we can go ahead and combine some like terms. 12 and 7, 19. All right, last step. Go through and combine like terms one more time. We've got a squared negative 3a and negative 3a, that's negative 6a, and a negative 4a, altogether makes negative 10a. And we have a plus 9 plus 19. So that's going to give us plus 28. And that's going to be our final answer for that problem. Any questions? If you have any questions, you feel free to post them in the comment section, or you can text me if you want. All right, so here we go. Next problem, we're going to graph the function. Here we have an absolute value function. We know that an absolute value graph makes a V. And so what we're going to do is make a table. And we're going to be very strategic about which x's we choose because we want to minimize the amount of work we do. So the first x that we want to pick is going to be a number that makes the absolute value 0. So negative 3 plus 3 is 0. So negative 3 is my first x. And then let's go ahead and work that out. Negative 3 plus 3 is 0. 2 times 0 is 0. 0 plus 1 is 1. So now that we have our first point, next, to strategically pick x's, since this is what I call the center point, this is actually going to give us the vertex of the V, we want to pick a number below negative 3 and above negative 3. So right below negative 3 is negative 4. Right above negative 3 is negative 2. And we don't have to go too far away. We're just going one on each side. And then we're going to plug those in and see what we get. All right, here we go. Negative 4 plus 3, that's negative 1. The absolute value of negative 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. So that's going to give us a 3. Now this negative 2 should also give us a 3. If negative 3, 1 is the vertex, then these points, since they're equidistant, should be symmetric. So let's see. Negative 2 plus 3, that's 1. Absolute value of 1 is 1. 2 times 1 is 2. 2 plus 1 is 3. And we do see the symmetry. Now we're just going to come over here to the graph, plot the points, and connect the dots. Here we go. 1, 2, negative 3 is up at 1. Right there. Negative 4 is going to be up at 3. So that's going to be there. And negative 2 is also up at 3. Now remember, we said absolute value makes a V. And so we just need to connect the points and make a V. And that is done. Next problem. For the piecewise function, find the specified function value. So here we want to find f of 6. That means we're going to have to go back here to the test zone. I like to call this the test zone. And we're going to take our 6 and test it to see where to put it. So whichever of these statements is true, when I plug in the 6, then that's the piece that I'll do. Get it? Wherever it's true, that's what you do. So is 6 less than or equal to 0? No. Is 6 between 0 and 5? No. Is 6 greater than or equal to 5? Yes, that is true. And so this is the piece that I do. Now since this is just x, that means the 6 is going to plug in for the x. And that function value is 6. And that is done. That one is done. And that's the end of page 2. Let's go to page 3. Let's see. For the pair of functions, we need to find, here it says f times g. So f times g basically means f of x times g of x. Well, f of x is x squared plus 1, so that's going to be x squared plus 1 multiplied by g of x, which is 6x minus 9, and that's going to indicate the FOIL method again. So we've already FOILed once in this video. Let's get ready to F it up again. Here we go. X squared times 6x, that's going to give me 6x to the third, because when you multiply letters, you add their powers. On the outside, negative 9x squared. On the inside, 1 times anything is itself. And last but not least, again, 1 times anything is itself. And since there are no like terms, that problem is done. Notice it is also in descending order, which is good math etiquette. All right, next problem. We want to find...
Captain, incoming message.
Sorry, it's my notification. Maybe I should turn those off. Bam. There we go. Silent mode. All right, here we go. Find f divided by g of negative 2. And so what that actually means, it means to find f of negative 2 divided by g of negative 2. And so here is our f of x. We're going to replace every x with negative 2. So that's going to be 3 times negative 2 squared minus 5 times negative 2 all over. Here's our g, plugging in negative 2. Negative 2 squared minus 3 times negative 2 minus 10. All right, so doing the numerator, negative 2 squared is 4. 4 times 3 is 12. Negative 5 times negative 2. Negative times a negative makes a plus 10. In the denominator, negative 2 squared is 4. Negative times a negative makes a plus 6 minus 10. And then if we do the little bit of arithmetic left, we're going to have 22. 4 plus 6 is 10. Whoops, 4 plus 6 is 10. 10 minus 10 is 0. Wow, does anybody remember what happens when you get a 0 in the bottom? That is undefined. So that answer was kind of tricky. Division by 0 is undefined. That's the answer we need. All right, next problem. Perform the following polynomial division. Since the denominator is a monomial, that means it's one term. That means we can simplify this problem by separating the one fraction into 3 separate fractions. So we're going to have 20x to the 8th all over 4x squared. Next, the sign is minus. We're going to have minus 16x to the 7th all over 4x squared. And then last, we're going to have a plus 8x to the 5th all over 4x squared. So what we do is we separate the one fraction into separate fractions, and then we can simplify each fraction individually. All right, so 20 divided by 4 is 5. 8 take away 2 is 6. Remember, if you have variables in a fraction, that a fraction turns into subtraction. Minus 16 divided by 4 is 4. 7 take away 2 is 5. And we have 8 divided by 4 is 2. 5 take away 2 is 3. And there's that problem simplified completely. And that's the end of page 3. Next page. All right, so here we have another division problem. This time we're dividing by a binomial. And so what we're going to demonstrate here is long division. We're going to divide this using long division. All right, so we're going to have 2x plus 5. And that's going to be divided in 2. Now notice that the dividend here has x to the 3, which is the biggest power, but it's not first. So we're going to have to rewrite this in descending order down here. Starting with 30x to the 3rd. Next, positive 8x squared. Next, plus 21x. And then the minus 3. So you need to have this dividend written in descending order. And also remember that every power has to be represented. So that means if I start with an exponent of 3, then I have to also have a 2, a 1, and a none. All the powers have to be represented all the way down to the constant. And now we can start the long division process. So we're going to take the lead term of the dividend and the lead term of the divisor, and we're going to divide those. 30x to the 3rd divided by 2x, and that's going to give me 15x squared. This is going to be the first term of the quotient, and that's going to go 15x squared there. And then we're going to take that 15x squared and we're going to distribute to both terms out front. Okay, so I don't really want to keep those lines, but that's what's going to happen. So 15x squared times 2x, that's going to be 30x to the 3rd. Notice that these match, they're supposed to. 15x squared times 5, what is 5 times 15 is 75x squared. Now, when I draw the line, I need to change the signs. Just remember, draw the line, change the signs, it'll work every time. And then we're going to have 30 minus 30, well, those cancel. 8 minus 75. Let's go to the handy dandy calculator. 8 minus 75 works out to be negative 67x squared. Next, the 21x can come down. And the minus 3 if you want it to also. All right, now, again, we're going to take the lead term of what's left here, the negative 67x squared, and again divide it by 2x. Negative 67x squared divided by 2x. That's not going to divide nicely. I'm so sorry. That's going to be negative 67 over 2x. That's going to be nasty. Negative 67 over 2x. And then that guy, again, he's going to distribute out front. All right, so here we go. Negative 67x times 2x is going to give me negative 67x squared. These should always match if you design this term in the quotient correctly. And then negative 67 over 2 times 5. Back to the calculator. Negative 67 over 2 times 5. That's going to give us negative 335 over 2x. Draw the line, change the signs. Draw the line, change the signs. These are going to cancel. All right, to the calculator again. We're going to have 21 plus 335 over 2. And that's going to give us 377 over 2x, and the minus 3 comes down. And we're going to rinse and repeat one more time. 377 over 2x, and that's going to have to be divided by 2x. Okay, so here we go. Calculator. 377 over 2 divided by 2. That's going to be 377 over 4, and the x's cancel. So the last term we need here is plus 377 over 4. And we do need to actually go ahead and complete that so we can figure out what the remainder is going to be. So here we go. 377 over 4 times 2x. Remember, these should match. That's going to be 377 over 2x. And for the final multiplication, we got 377 over 4 times 5. Calculator time. 377 over 4 times 5. Whew! 1,885 over 4. Plus 1,885 over 4. Draw the line. Change the signs. Cancel. Now, calculator time. -3 minus 1,885 over 4. The survey says negative 1,897 over 4. That is the remainder. Okay? And this up here is the quotient. So the way you would give that is you would say 15x squared minus 67 halves x plus 377 over 4. That's the quotient. Negative 1,897 over 4. That's the remainder. And that was super nasty. I'm so sorry. Maybe the actual one on the test won't have nasty fractions. Okay, next problem, number 9. We're going to find f circle g of -8. This is composition. And so that means we're going to do f of g of -8. F of g of -8. And so the way we work this is we start on the inside and we work our way out. So -8 is going to plug into g right here first. F of, plug in -8 in for every x. That's going to give me 6 times -8 squared minus 2 times -8 plus 9. So where did I get all of that? That's from this function replacing every x with -8. And then I need to work that out. So I'm going to go to my handy dandy calculator because it's a little bit faster. That's going to be 6 times -8 squared minus 2 times -8 plus 9, all at one time on the calculator, 409. And next step, we're going to take the 409 and plug it into f. So coming up here to f, we've got -3 times 409 minus 9. And then we need to work that out, and that'll give us our final answer. Again, I'm using the calculator. -3 times 409 minus 9, -1,236. And that's going to be our final answer for that problem. All right, next problem. Find the composition, f circle g of x. It says then write the domain. We're going to have to write the domain in interval notation. So there's two parts here. Find the composition and then write the domain. So remember, f circle g means f of g of x. And that means that we're going to plug all of g of x into f of x. All of this stuff plugged into f. And so that's going to give me the square root of 5x minus 30. Bam, and that's done. That is the composition. Now for the domain. We know that a square root has to work out to be positive. In other words, the stuff under a square root called the radicand, that's going to have to be greater than or equal to 0 since you can't square root negative numbers. So what we're going to do is we're going to take the radicand and we're going to say, hey, that stuff has got to be greater than or equal to 0. And then we're going to solve that for x. So we're going to add 30 to both sides. Those cancel. 5x greater than or equal to 30. Divide by 5. And that's going to give us x is greater than or equal to 6. Now this, the way this is written right here, this is called the restriction. Okay. What we need to do is turn that into the domain. Okay. So if we look at this on a number line, we know that at 6, x has got to be greater than or equal to 6. So the greater than or equal to says that's going to be a solid dot, and it's going to shade everywhere bigger than 6. So that's the values that x can be. Everything starting at 6, including 6 because it's solid, and greater than 6. So how do we turn that into interval notation? Well, interval notation says describe what is shaded. So since the dot is solid, we're going to have a bracket, and the shading starts at 6 and goes on forever. And so that means it's going to be 6 to infinity, and that is interval notation. So there's the answer to that problem, the composition and the interval notation. And that's the end of page 4, okay? So what I'm going to do is I'm going to stop this video, and then we're going to continue the rest of this in a separate video.